Hey gang, what's going on? Welcome to session 5 of our 6-session cyber forensics workshop. I'm going to be extra chipper this week because I just passed a certification exam that I've been studying, I don't know, 150 hours for. So yeah, I'm in a pretty good mood. Anyways, in chat, we've got one person over here. Hi. And I've uploaded a couple things actually. I uploaded some example HTTP 206 response code packet captures into the resources folder on our Google Drive share resources. I think I put it there. Let's find out. Yep, I put it in the resources folder. And I also uploaded the draft for this session's notes. And I have those open here. So let's go ahead and just focus on these notes and start it off. Here we go. All right, let me zoom in a little bit as usual. Okay, so session 5. I will provide the link to the recorded session when I have one available, when YouTube is done processing. Here's the link to the Google Hangouts page. By the way, if you go to this link, you can watch the recorded video from there. So, for example, if you just don't want to wait for me to upload or send out the URL for the recorded video, just go to this URL a little bit later, and as soon as YouTube is done post-processing, you'll be able to take a look at the video. So, review for session 4. In session 4, I assigned the level 6 challenge. I had one person go through it, or excuse me, I had one person contact me with a question, and I provided some assistance, and it was great getting the response back. It was like, oh man, that's cool. Like, yeah, I know. It's really cool. So this one's pretty fun. I gave you guys a heads up because I think I posted these notes to the Google Drive a couple days ago. In fact, let me make sure I even actually uploaded it. Yeah, they're sitting there. So I uploaded those a couple days ago. And in the notes, I gave you a big hint. And, well, heck, in the notes, we go through the entire thing. So, I mean, there's the hint. But I started off by calling level 6, do you hear that? And the reason I chose that is going to be fairly obvious coming up. But in this case, I've gone through and I've pretty much documented exactly what you need to do in order to get the answer. So if I go through in the video and I show you how to do it, but you're thinking, I like to read stuff, well, here you go. I have the entire breakdown right here. So let's see, do I show the, yeah, I sure do. Yeah, it goes through all the steps. We're going to basically just go through what I've written out here. I do want to make a note, and we're going to experience it in person, live, is Wireshark 1.10.2 on my Kali virtual machine kept crashing when I was trying to, well, I guess I already have it highlighted so I can say it. There's some embedded audio streams that we're going to be farting around with. Kali kept crashing when I tried to decode those. I've tried to give that sucker more memory. I've tried everything except for moving away from that exact version of Wireshark on Kali because I refuse to move away from a stable build that is not stable. If I can't make it stable, I have this obsessive compulsive tendency to try to make it stable. I don't know why I do that. So anyways, we've already identified 2 bugs previously. This is a 3rd one. The Linux branch just is not stable in this version at all. So, what are you going to do? As such, I have my Windows XP malware VM ready to rock, and we'll do it in there. Alternatively, I have a Windows 7 one, but you know, well, I've got a bunch of VMs if we need to, but it works just fine on the Windows XP one. So we're going to run through this packet capture, and although I have it written out here, right, starting right there, we're going to do it the way that I did it when I first came across this challenge. So let's switch windows here. We're going to go to my Kali virtual machine. Hey. And see, share out the window. Kali. Share. Cool. I want to note that in Kali, if you can see my mouse right here, up at the very top of the window, top center of the window, it says Kali Linux 1.06. I've actually updated to 1.09, so just want to throw that out there. Okay, cool. Here we go, right here in the Session 5 folder. Alrighty. Cool. Let's see. Hey, come here. Oh, you don't want to go left? Whatever. Alright, you go away. Cool. So to start this off, we have our HTML explanation file, and then we also have the packet capture. So let's open up the HTML file and take a gander. And it starts off as Jack is wrapping up the case. He learns that the mystery is far from over. Using the level 6 packet capture, use the level 6 packet capture to learn more about the mystery and to answer the following question: who killed Gregory? All right. And then here you go. Submit your answer to your instructor. This is the last round, so you get plus 1,000 points if you get the answer. Points mean absolutely nothing, but why wouldn't you want 1,000 points? Seems important. You should do it. So, Patrick, you got 1,000 points, man. Plus 1,000. Oh my goodness. You should put that in your LinkedIn profile. All right. Anyways. So, let's take a gander at the packet capture itself. See what we're doing here. All right. Now, this packet capture, there's something that should stand out immediately as soon as you start looking at this thing, and it'll become evident as soon as we start scrolling through. So as always, one of the first few things you want to do is go to Statistics and then Protocol Hierarchy. Make that window bigger. There we go. Now, something should immediately stand out to you as a, ooh, look at that. So, in fact, I can fit just about everything on my screen here. So you'll see that everything's part of a frame, obviously. So yeah, everything in this capture is visible on this window here, even given the view that we have. So if you take a look here, 100% of the capture is Ethernet. Cool. 99.8% of this capture is IP version 4 based. Cool. 97.9% of that is user datagram protocol, UDP. UDP is a connectionless protocol. Connectionless, that doesn't make any sense. It's a stateless protocol. Connectionless is the term that's used, but it doesn't make a whole lot of sense because there's still a connection being made. But check it out. Let's just Google for UDP, and it takes us to, hey, look at this. A good old Wikipedia article. These are hit or miss, but as you've seen by now, I love reading these. Now, the real guy you want to read is this guy right here. If you remember, I think it was last session, I talked about the request for comment articles. And we click this guy right there. Hey, this is new window. Oh, whatever. All right, do it the manual way. Request for comments 768. That's old school. Check that out. August 28th, 1980. What? Were some of you born before that? I wasn't. So check it out. User datagram protocol. And it outlines the protocol to be used. And up top it says, it's defined to make available a datagram, blah, blah. That's boring. Blah, blah. That's boring too. Well, anyways, you can read this later. I'm going to go back over here. And let's see. All right, here's the thing we need to focus on right here. Zoom in. Come on. There we go. UDP uses a simple transmission model with a minimum of protocol mechanism. It has no handshaking and thus exposes any unreliability of the underlying network protocol to the user's program. As this is normally IP over unreliable media, there's no guarantee, here's the kicker by the way, there is no guarantee of delivery, ordering, or duplicate protection. So if you're familiar with the TCP protocol, which you should be, and by the way, that's a bit of that's RAS syndrome, redundant acronym syndrome, because TCP stands for Transmission Control Protocol, so I can't very well say the TCP protocol because I'm saying protocol twice. But anyways, in fact, is that on the internet? RAS syndrome. Oh, good, it is. Yeah, redundant acronym syndrome. Love it. You know, like PIN number, right? All right. Anyway, sorry, I had to open that up. Okay, so UDP, what is it normally used for? Well, if you're familiar with TCP, TCP has a bunch of really cool error checking and delivery ensuring mechanisms. For example, one of them is called sliding window, which deals with congestion in a very elegant manner. Well, you can call it elegant, but it's actually pretty silly when you look at it. Luckily, our pipes are big enough and fast enough these days where we don't notice the sliding window in effect for the most part. So, in fact, let me just Google TCP sliding window. Hey, there we go. It's using TCP. Reliable in-order delivery of packets. So yeah, check that out later if you want, or if you don't want, whatever. I closed it. Moving on. So here's the deal. UDP does not do any error checking whatsoever. It also doesn't check to see like, hey, did you get that last packet? It just delivers it. And on the other side, hopefully it received it. So because of the error checking and sliding window and other kind of cool stuff that's baked into TCP, UDP is used for stuff where you just need data to get there quickly, like very, very quickly. So I'm going to digress one moment and slide over here. So this is pretty random, but I just thought of this. Can you see these books? Are they backwards? Well, that's not going to help anyone. Well, whatever. All right. So this is wide area networks. Whoops. There you go. It covered my face. And this is local area networks. And these are both written by Reagan, right? Yeah, Reagan. Whoop, whoop. There you go. These are the two best books that I have ever read. You can see the width of both of them together on local area and then wide area networks. That's where I learned about stuff like sliding window being part of TCP. So these are probably fairly old, but if you're interested in a really, really good textbook, these suckers should still be available. I assume. Let's find out. Whoops. Hey, what are you doing? All right. Local area networks. Oh, I'm not sharing my screen. Hold on. Sorry. Got carried away showing you some books. Let's go back to Cali. Here we go. Oh, what is this? I don't know what that is. Some ad. All right. Hey, there it is. Oh, he doesn't have any new stuff. Oh, wow. Apparently it's a well sought after text. $237 for a used copy? Wait, what? Hold on. Oh my goodness. I have an extremely expensive book. Well, no, there's something different here. Something's wrong. No, okay, I'm just blind. There you go. Yeah, there you go. 39 used from a penny. There you go. 1 penny or $4 of free shipping. Here, someone go buy this. It's definitely worth the read. Anyways, the local area networks book is my favorite one. The WAN one's cool, but I'm more of a LAN guy myself. So yeah, the book is fantastic. I will put a note about it in our notes. Let me just scroll down here. Regan text links. I'll give you some links on that. All right, back to UDP. UDP is typically used when you need data delivered quickly. When do you need that type of data? Well, it's usually used for voice communication, video communication. Most online games use UDP. In fact, any decent online game will use UDP to transfer data because you just need to send it quickly to the server so it can send it to everyone else. And if you have a few frames dropped here and there, whatever. Well, you're not going to drop a frame. If you have a few, well, yeah, you will. You have a few packets here and there that get dropped, who cares? Whatever. Your data will get there. So think about it this way. I have a file that I'm sending you, and it's a bunch of zeros and ones, right? And some of those zeros and ones just drop out, and they're not there. And you get the file, and you double-click that file. Windows is going to, well, Windows will just tell the linker to open it with a file handler. Word is what I'm getting at. Will open the file, or attempt to, and then all of a sudden it's going to say, well, I don't know what's going on there. It's just not going to open it, right? I mean, you're missing data, a chunk of data out of a file. Good luck with that. But when it comes to transferring voice, let's just say I'm transferring voice like I am right now, which, by the way, this is being transmitted via UDP. It's what YouTube uses as UDP. So you drop, like, what, 5 packets out of, I don't know, a million or something, and is that really going to make a difference in the voice quality? No. You might hear, like, a little blip in the audio, but you're not even going to miss, like, an entire word, so whatever. So UDP is used for that type of delivery. In general, when you see UDP used, I'm going to switch back over to Kali here. There we go. When you see UDP in use, it should give you a heads up that you're most likely not using a standard type of protocol that's going to be associated with like a known application or something. What you might be using is audio or video. It usually just gives you a heads up on that as far as forensic analysis is concerned. So anyways, we see we have a bunch of UDP traffic, right? Well, what is most of this UDP traffic? Real-time Transport Protocol, RTP. So if you look here, 96.98% out of this entire capture is RTP traffic. Okay, let's go take a look at what that is. So in fact, let me do something first. You can filter on the data. In fact, I guess I could have just done it from the protocol hierarchy. I can, as we've done before, right-click, apply as filter selected, and look what it does. The filter it sets up for me, let's walk through it. It has to be RTP and UDP and IP and Ethernet and frame. So if you just walk back up the network stack, frame, Ethernet frame, IP, encapsulated, UDP traffic, RTP. Or, to make our life simpler, watch this. We delete all that silliness and we just type in RTP. And we apply it. Hey, there we go. Now what we can do is we can, statistics, and then go to summary. And if you remember we did this in one of our sessions, we see right now our display filter is set to RTP, right? How many captured packets do we have total? 9,764. How many are we looking at right now with a filter of just RTP? 9,490. How much is that? 97.194%. What? What about bytes being transferred? Because technically you can have a lot of bytes transferred in very few packets, right? Well, it's also the bulk of the bytes being transferred. So if you look down here, if you can follow my mouse, look at this, where it says bytes, how many captured, how many are being displayed, what percentage? So of data actually transferred, 97+% still. So fairly easy to see that this packet capture contains mostly RTP traffic. Let's pretend like you don't know what that is. Maybe you don't. Let's open up good old Firefox here. Well, Iceweasel, the Kali version of Firefox, and then go over to, what am I doing? Oh, RTP. Oh, hey, look, Wikipedia. I like Wikipedia. Although I am let down that I don't have a $200 book. For a moment, I didn't know how to, sort results on Amazon. Sheesh. All right. Real-time protocol defines a standardized packet format for delivering, wait for it, audio and video over IP networks. Ooh, audio and video. So we have UDP in use, specifically RTP, so there confirms that we do have most likely audio and or video. So it says here it's used extensively in communication entertainment systems that involve streaming media such as telephony, video teleconference applications, television services, and web-based push-to-talk features. Ooh, push-to-talk, when you click a button and you talk? Hence the term, push-to-talk. All right, and then you can scroll through, and oh goodness, there's all this stuff in here. How sessions are initiated, by the way, is fairly important. And look at that right there. We'll come back to that later. Profiles and payloads. What type of encoding might they have? The audio payload formats. Here are some audio methods. Oh, look. Good old DTMF, dual tone multi-frequency signaling. Ah, telco, the non-rotary version of a standard telephone uses that. Anyways, and then here's what the packets look like. Real forensics, let's get in there, right? That stuff's like, and you can read through that, blah, 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 blah. Okay, so let's digress on that point and come back here. Let's try something else, though. So I know that the bulk of this packet capture is RTP traffic, right? Well, one thing you want to do, especially in the world of forensics, is you don't want to focus on something and completely forget something else. Meaning, if you see RTP taking up 97% of the data and the packets that were captured on the wire, you might not look at what else was on the wire. So let's not do that. let's not ignore that. How do you do that? Well, speaking of not, if I just put a bang, typically called a bang, but an exclamation point before RTP, and I hit apply, it's going to show me everything that's not RTP in this packet capture. So now what I want to do is I go now to the protocol hierarchy and look up here at the very top. I'm not sure if I mentioned this before. I probably should have. Where it says display filter, not RTP. This protocol hierarchy, it will show you the hierarchy based on your current view or based on your current filter. So might have mentioned that earlier in like session 1, but hopefully you guys noticed that. Maybe you were looking at the hierarchy after you had a filter applied and you're thinking, what the heck? This doesn't look right. Yeah, sorry about that. So anyways, all right, what are we looking at here that's not RTP? Well, everything's a frame, Ethernet frame. All right, we have some IP version 6 stuff going on here. UDP, it's just DHCP. All right, well, you know, trying to get onto the network. And then TCP, Session Initiation Protocol, SIP, S-I-P. What's that? We also have some UDP. Wait a minute, this looks familiar. Real-time Transport Control Protocol. What's that? RTCP? And then we have NetBIOS, and then our SMB mail slot, which is just noisy from a freaking Windows machine. Hey, look at me. Look at me, I'm NetBIOS. Oh my goodness. And then we have some ARP stuff, which we'll be dealing with later in the session. So, okay, what I want to know are, well, let me rephrase this. What you should want to know is when you're looking at this, what are the things you don't recognize? So, simple network management protocol, you should probably be familiar with that. If you're not, it's UDP based and it's used to control network hardware, appliances, switches, whatever you want to call them. I mentioned that in some previous session. We even took a look at the traffic. DNS is, you know, trying to just resolve names, so standard. This, though, is probably something with which you are not familiar. And the same thing can be said about, oh, sorry, I skipped it, that guy. So we can look at it here, or we can just do the following. I'm going to close this. We have our filter, right? Not RTP. Let's just scroll through the freaking thing. There's not a lot to look at when we're filtering out RTP. So we have some SNMP right up here at the beginning, and whatever. And then all of a sudden we start getting this SIP stuff. And check it out. I mean, visually, you can just see we have something funny here. First off, someone's trying to use a proxy, it looks like, proxy.sipthor.net. Never even heard of that. I've never noticed that. So there's that. Anyways, we see SIP, and then look right here. What's this say? Request invite SIP. V. Jensen at sip2sip.info. What? And then look at this clear text protocol decoding done by Wireshark. Thanks, Wireshark. Status 100, giving a try. I like that terminology. I'm going to give it a try. 407, proxy auth required. Request ACK-SIP. Request invite. Giving a try. Another invite. Different name there. SWJIOXFB. And then all of a sudden we have an outbound SIP protocol going to an ephemeral port, a higher port. So this might be actual traffic there. And it looks like we have a response here. Wait, is that the response? No, that's something else. But they are definitely related. And that's a 50, that's a 55. Oh, no, they're not. Well, whatever. And then, hey, look at this. Ringing. What do you mean ringing? Like a telephone? Ring, ring, ringing. Status, okay. What do you mean okay? Well, it was ringing, and now it's okay. Well, what does that mean? Another okay. A couple different calls going on here. Okay. Okay. Sender report. What's this? What is a sender report? That's weird. If you follow this stream, we have source description, RTCP. So RTCP protocol does a description and then a report and then a goodbye. Goodbye. Reminds me of the old AOL days. Remember that? Goodbye. Okay, anyways, let's go back up to the top here. Well, without even going to the top, you can see that most of this packet, like I'm just scrolling up here. Scroll, oh, first off, excuse me. Hold on, what are you doing? Okay. Anyways, you can see that most of this traffic is SIP or, where did it go? RTCP is in there, but mostly it's SIP. So let's say you don't know what SIP is. So you go over here. Here's Google SIP. Hey, look at that, Wikipedia first thing. Session Initiation Protocol. Okay. The Session Initiation Protocol is a signaling communications protocol widely used for controlling multimedia communication sessions, wait for it, such as voice and video calls over IP networks. You're probably thinking, well, yeah, I know. We already have audio and video stuff going on here. I'm just going to tell you right now, most of the time when you see SIP involved, and especially when you see stuff like ringing, you're usually going to be dealing with a call. Well, I mean, obviously. What's that call typically going to contain? Well, these days it typically is an audio-based call, like a Skype call, but it's quickly changing to becoming video calls. For example, one of the current issues right now in the forensics realm is, and this is giving a hint toward what we're going to be doing or talking about in session 6, is decoding FaceTime traffic. Or I should say decrypting, really, because it's encrypted, and that's a problem when it comes to forensics. So anyways, we see all this stuff in here, and you're like, all right, well, that's cool. So now what? Well, this is where the fun comes in. Wireshark does a lot for us. A whole lot for us. So one of the things that Wireshark will do for us is it will let us get a really good view on what's happening, and when we really want to focus on something, Wireshark has all the decoders that we need. So let's say that I want to say not RTP, and I also want to take out SIP because I want to see what else is in here, right? So to do that, you use this and, just like in C, and you say, and also not SIP. And you apply that. We're looking at not RTP, not SIP. What else do we have in here? Not a whole lot. And you can scroll up and down here. And in fact, if you want to take out and not RTCP, I don't want any of that video or audio stuff. So what else do I have? Not really a whole lot. Well, I have here MDNS. I think I'm blanking because I don't know what MDNS is. Oh, yeah, I do. Yeah, I failed. Sorry. Multicast DNS. Yeah, we're not going to touch this. It's just DNS. Whatever. You can look that up later. That goes into a whole other realm. That's, by the way, also in the Regan text. It's in the local area networks book. I love that book. Go buy the book. That's like $5, man. Go buy it. Or buy the $200 version, just so you can say you have a $200 book. I don't get. There must be a certain printer or something. I don't know. All right. Anyways, so at this point, I'm like, all right, this is boring. There's nothing here I care about. And hell, for that matter, if you look here, I take out SIP, RTP, and all this, and I still have most of my TCP stuff. It's going out of a SIP port, so it's probably still some type of SIP traffic. No, look at that. If I focus on this, check this out. So hold on, let me start back over here. Oh, you took my freaking thing out. Oh, there it is. All right, so I have this filter on, right? And I start scrolling down. I'm like, okay, SNMP, whatever. Hey, here's some SIP stuff. What's this? The first thing I find is in frame 7. Right-click, follow stream. 1 byte missing in the capture file. Wow, that tells me nothing. Thank you so much for that. Let's go back. By the way, your filter history is right here. So there's that. But here we go. Okay, well, I'll keep scrolling here. And then all of a sudden I see more TCP traffic coming off the SIP port. And I say, oh, okay. Right click, follow TCP stream, bam, check it out. Starts off with invite, SIP 2.0. Okay. From Jack Stone, SIP at Jack Stone, or no, excuse me, SIP protocol, Jackstone at sip2sip.info to V. Jensen. So Jack Stone to Victoria Jensen, Mrs. Jensen. All right, and what do we care about? What's going on here? Invite, what do you allow? These are the different things it allows and whatever. User agent, Blink, 0.27 on Windows. The user agent string, if you're not familiar with that, defines the client that's being used. The user agent is another term for the client. In other words, the program that's at play here. These can be spoofed beyond easy to spoof these freaking things. But let's just pretend like this one's not been spoofed and find out what Blink is. One good way to find out what software is being used is to just do a literal search for the user agent string. All right. These look like they're just in examples. All right. Do over. Blink. Click. Blink 027 for Windows and call it. Oh, this is a no. This isn't what I want. Where's the project page? Where's the project? Oh, wait a minute. Oh, gonna get inappropriate advertisements. No. I'm clicking on stupid things right now. Where's this go? Sip simple? What the heck? What? All right, kidding me? I can't Google right. Oh wow. Okay. Derp. There you go. Blink is the best real-time communications client using SIP protocol. You can use it with many SIP providers such as SIP to SIP, a free service. Check it out. Blink for Linux and Microsoft Windows. Click here to download. I don't want to download it. Give me screenshots for me. I think these are all screenshots. They're all miniaturized. What's this? Hey, there we go. Oh, there's a screenshots page. I'm actually on the screenshots page. Cool. So adding an account, and then there's your contacts. Contacted. Cool. James Bond. Awesome. Preferences. So it looks like they were using this program here. Let's just ignore my Google failing to find this. I don't know why this didn't find it easier. Actually, yeah, I do know, because when you specify a version along with the client name that you're looking for, you're going to find a lot of people in help forums, just like we found, who have captures that they're trying to get assistance with. Because the Blink website's not going to have the embedded user agent strings. It's rather just going to have the name of the program, which is why when I searched for SIP Blink, I immediately found the program. If I search for Blink and then a version, I'm going to get a bunch of packet capture examples that denote the specific version in use. That's a very logical thing. So, yeah, I should have just searched for SIP Blink right off the bat. But anyways, moving on. All right, anyways, we're using SIP Blink, and then there's an IP address involved and some stuff. And hey, check it out. Giving a try. And then there's some more information on who's doing what. And the server that's running SIP-Thor on OpenSIPs. So here's a server that's transacting this stuff. Brokering is what I'm trying to say. And authentication required. All right, let me authenticate. And then sending an invite. And then stuff. And then routing information. And then cool. All right. So, clear this out. What do we really want to do here? Well, I'm going to show you two things. First up is doing this. Looking at the decode, I randomly clicked on one of these SIP packets. It's in frame number 21. And then you see Wireshark does this decoding for you, right? Frame, Ethernet, IP, TCP, SIP. Click it. Status line, giving a try. Message header. And there's the header of the SIP message. So this is the stuff we were just looking at, but I mean, you can look at it, you know, the way that it's actually being decoded straight from Wireshark, and you also get this cool field value stuff set up. You can do some really cool parsing, like creating your own packet capture in Python using Scapy or PCAPy. If you don't use PCAPy, that's horrible. Use Scapy. But you can pull this information out yourself. Moving on. Okay, Wireshark sure can decode this stuff. What else can Wireshark do for us? Well, if you haven't noticed it yet, take a look up here. There's a menu, an entire menu in Wireshark entitled Telephony. Check it out. And look down here. SIP. For that matter, look up here, RTP. What? Show all streams. So again, you just go to telephony, RTP, show all streams. And look at that. These are all the streams. It even shows you the amount of jitter. What? Yeah, jitter is a quality of service thing. It's a latency, jitter, and there's another primary one that I'm blanking on right now. Latency, jitter, delay, latency. Yeah, I'm blanking on the other one. Quality of service is another bag of stuff. We're not going to touch that right now. So I have some calls here, some SIP-based, or excuse me, some RTP calls. Right down here at the bottom, see it says analyze? I can choose one of these, or 2 at a time. For some reason I can pick 2 at a time, but not more than that. That's kind of odd, but you know, whatever. So I want to pick this one here, and I say analyze. Ooh, and I get this. Oh, and Wireshark crashes. Yeah, about that. So the Kali version of Wireshark does not like telephony. So we're going to switch over to Windows XP. One moment. I'm just going to switch over to a different virtual machine. There we go. You see that? Yeah, cool. All right, cool. So, session 5, level 6 PCAP. And I purposely did not update my Wireshark running in this Windows VM. I don't want to update it because, well, this one's working right now. So I'm just going to leave it alone. This is version 1.6.5. It's pretty old. But here's a telephony menu. And check it out. While I do have RTP here, there's something else I want to show you, but I'll get to that. I still want to show you the RTP, but see this right here? VoIP calls? Even has a picture of a telephone. Huh? How cool is that? But we're going to find our answer here, but let's just use RTP for a moment. I go to show all streams, and here are my streams again. And let's say I pick one, so I'll just pick the first one, and I click Analyze. And I get this stuff. I get the forward direction and the reversed direction and all this fun stuff, and I can do analysis. Yeah, I don't want to do that. So if I double click on one, yeah, okay, double click does nothing for me. Detected 8 streams. Choose one for forward and reverse direction for analysis. Yeah, that's cool. Or not. That's boring. I want to go just over here to VoIP calls. And detected 2 VoIP calls. So check out what Wireshark does for us. This program is ridiculous. It tells me, hey, they were using SIP. And it says it was completed. So it was actually a completed call. Oh, okay. So between who? Well, one is between Jack Stone and Victoria Jensen. And the other one's from Betty to Jack Stone. Oh, cool. So I click on the first one, and I click player. And then I click decode. Oh, wow, look at that. Check it out. Yeah, Wireshark just says, okay, you want to listen to those calls? And you can listen to the calls. So let's mark all these and then hit play. And let's see, is my... Wait, not at the same time. Get out of here. All right, I don't like that idea. Do over. I'm just going to mark the first one, hit play. And here we go.
Hi, this is Victoria. Hello, Victoria. It's Jack Stone. I just wanted to call and give you an update about your case. Turns out, Gregory wasn't cheating on you at all. However, I do have some bad news about Sir Gregory.
So this is Jack Stone talking to Ms. Jensen, and her part of the audio is over here, but it's too low to hear. In fact, most of this you probably can't hear very well over the mic, but I'm going to let it play out anyway.
You killed him? I kind of think you might be wanted for murder, so about that.
Okay, so we couldn't hear what she said, but then he says, you killed him? Oh, you might be wanted for murder. So let's play this stream over here. From this point, go away, play.
Hi, this is Victoria. Hello, Victoria. It's Jack Stone. I just wanted to call
He's saying the same thing, but
turns out Gregory. You killed him? I kind of think you might be wanted for murder, so about that.
That's just duplication replay. But here we go right here. This is on the other side. Click, undo, and play this one. She says, "You're too late. I already killed him." So, she killed him. Aww. That's it. That's the answer, by the way. She killed him. And he wasn't even cheating on her. And for the heck of it, we can go play this one too. Player, decode. Just listen to the first one.
Hello?
Not much here. I'm waiting. Yeah, these are too low. It's pointless to play. Now, you can listen to these later if you want. But the real thing is what we've already discovered. So the call between Jack Stone and Victoria, she says she killed Gregory. So Gregory is dead now. But who killed him? Who killed him? Victoria. And the initial question was, go away, who killed Gregory? The answer is Victoria. So it wasn't Betty at all. All right. So that was the assignment. That was the walkthrough. That was the final portion of that particular challenge that we were going through. And I'm going to go ahead and transition now. Change my screens. Hey. I'm going to go back to our notes. All right. And the second thing that we're going to be looking at here, the HTTP 206 responses that we started from last time. So we're switching up our gears at this point. It's over now. More on challenge-related stuff next session. In fact, the entire next session, I'm just going to be doing some hands-on stuff and rolling through various challenges and pointing you to different resources where you can do the same. But anyway, HTTP 206 responses. Last week, I had you guys check out 206 responses, and there's a Wikipedia article here. Let me open this and there we go. And Kali, which is not being shared out right now, which is fine. But the screen here says, for a 206 from Wikipedia, the server is delivering only part of the resource, a byte serving, due to a range header sent by the client. So why would a client send a range header as opposed to just give me all the data type of thing? Well, it says the range header is used by tools like wget to enable resuming of interrupted downloads or split a download into multiple simultaneous streams. So when you see those things that are like software downloaders, you know, those download efficiency things that are just a complete joke and you need to stay very, very far away from, those things typically send 206 style requests, and so it'll come back with an HTTP 206. We started off looking at one of the articles that is on our site. And by the way, I should have mentioned this. The site that we have that we run with a couple different co-workers, we don't use our real names on there. You'll notice that we use code names. So please don't, if you post a comment, which I definitely welcome you to post a comment, please refer to people by their names. So for example, my buddy Mike, his name on the site is Interdimensional Shambler. Oh, that's nerdy. I like it. My name is 8 Bits of Brain on the site. So if you're going to refer to us, just use those names. Those guys are weird about keeping that stuff, you know, separate from our actual identities. Yeah. All right, I also found an article related to 206 fragmented packets coming into the network. This article that I found, luckily, it provides this guy right here. So it gives sample PCAPs. We don't have sample PCAPs yet on our site. Eventually we will for a bunch of stuff, but right now we don't have them. So let's go take a look. Let me switch my screen back over here. And right there, there's me and Callie. Cool. All right, so here's the, again, 206 response, partial content. I'm just on the Wikipedia article for HTTP status codes. Partial content right there. All right, close that up. So interdimensional shambler, we'll call him that instead of Mike, has his article here and gives us some examples and stuff. And then down here, we get to the part about 206 responses, partial content. All right, and he says that you basically find the desired data, follow the streams, save it as raw, and then carve the objects from the stream data. Well, it seems simple, but then he gives a visual, which gives you some idea here. The white area is the full file, blue is overlap between other streams, and then red is overlap between the continual streams. So we're going to look at an example. The first one just has 2 packets, which makes it kind of easy. Usually if you have 206 data, you don't just have 2 packets. You have more than that. So it may break it into multiple streams, I should say. Not packets, but streams. So sometimes you'll have 3, 4, 5, 6. It depends on what the client decides is a good number for being able to resume a download after certain chunks are downloaded, pretty much. Okay. His article goes on and shows you some stuff, gives you some visuals, and breaks down some numbers. I found another article, very similar. This one here from Charles Smuts. Who is this guy? What else does he do? Let's see. He's a software developer who focuses on computer security, incident response, and sophisticated threats. Cool. I already like him. Let's look at him. Hey, what's going on, man? I wrote this article. Woo! All right. That was him, I swear. So we scroll down. He talks about partial 206 stuff. He goes into depth. Well, here's what he does. This is what I like. He gives examples. Yay! So I took the examples and I put them on our drive share. I put them in the resources section, as I mentioned when we started off. So without going through the articles in depth anymore, in fact, let's close those up. Let's go take a look at the examples. So we have example A, B, and C. I'm going to open up 206 example A. And again, this is in a zip file on our drive share called 206_examples. And for that matter, the Word doc gives you a direct link to it from his site if you want to go check it out there. So I'm going to open up example A. And here's what you get. Check it out. We see our HTTP GET request. And remember, a GET request is just what it sounds like. I want to get a resource. So instead of getting a 200 OK, I think I skipped it. Where'd it go? Am I blind? Oh, yeah, I am blind. It's right in front of me. I get a 206 partial content. What is it? Well, it's a PDF. See? Right there. It says PDF. For that matter, don't forget, Wireshark filters are fairly important. I can do http.request.method. And I see that I have 2 gets. If I want to be specific, I can do equals get, which in this case will show me the same content, or I can do, if I want to look for posts, but there's no posts in here. And the other thing I can do is I can search for response codes. The cool thing about the Wireshark filters is ever since version, actually I don't recall, I think it was 1.0. No, you know what? I had no idea actually. For a while now, you've been able to type out your filter and it tries to do some auto-completion for you. So there's HTTP response code. And even if I don't know what code I want, I can search for that and I can see response codes. So I can see a response. Check it out. I have 2 different response codes, 206s. Oh, okay, cool. If I right-click on this, actually, you know what? Hold on. Let's start at the top. I have a get for a PDF. Let's evaluate this get. We're going to evaluate it because it's going to show us why 206 is even involved here, okay? So we have a get for this PDF. GMU CSTR 2010-20.pdf. What is that? I don't know. It's from a school or university, excuse me. What is this? Is this real? I don't know if this is real. Oh, sure is. George Mason University. Cool. That's a good school. All right, so some PDF here. Let's see if it's still alive. Yep, it is. All right, it's a paper. Oh, that's cute. Check it out. Smuts, this guy's article. So he used his own PD's published a paper here. A scalable architecture of deep network analysis. Oh, I like this guy. This paper could suck. I'd still like him though, because he's into this stuff. So was this peer reviewed and published? Or was, oh, it's for the school. Okay. Cool. Maybe he teaches there. You got to publish X amount of papers per year and so on and so forth. That's total guess, by the way. He might have been a student. I don't know. I'm already over that. But we know that we have a PDF that was requested, right? Well, what did the client do? First off, what's the client? Well, in this case, the user agent string starts off with Mozilla 5, which indicates usually Firefox, on Windows, specifically Windows NT Core. But then all of a sudden we have Apple WebKit, and then Chrome, and also Safari. This is a silly-looking user agent string, if you ask me. It seems to have conflicting info. But you know the cool thing about user agent strings? You just Google them. Looks like we found a near hit. All right, we don't have an exact hit. Start bleeding. Oh, there's a hit. Chrome Plus. What the hell's Chrome Plus? Chrome Plus is all the functionalities that Google Chrome has, plus some features such as mouse gestures, super drag, IE tab. Oh, okay, whatever. Never even heard of that. Which is why we're seeing this weird. And look, the Safari thing. What's the difference then? Oh, the difference is that's the only difference. So in that case, I'm going to say that it looks like they were using Chrome Plus if this user agent string wasn't spoofed. In fact, now I'm just interested. Hold on. Chrome Plus, one word? Ooh, what is this guy? Cool Novo browser. Never heard of this thing. What? Where's like basic? Oh, this is boring. Come on. Give me the nitty gritty. I don't want this stuff. Oh, here, what's this? That's boring too. This is all boring. Is there a Wikipedia article on this? I like Wikipedia articles. Oh man, let's do this. Watch this. Watch. Cool Novo. Wikipedia. Hey, I win. Here. I wish pages could just have decent information like Wiki does. Oh, wait a minute. What language is this? This is not what I want. Where's translate? Well, let's just read it. It's a version of Chrome. Used to be Chrome Plus. It's produced in the Netherlands, obviously. And it's currently at that version. Made by Maple Studio. Alright. That's enough. Oh, hi. Yeah, learn to Google, man. Come on. Jeez. Yeah, that's the same thing we already read, so whatever. Okay, well, I've never heard of that. I would not trust it personally just because I've never heard of it. I would have to research the heck out of it before I use it. This is not an advertisement to go grab that browser, but if you want to try it out, do it in a VM first and be careful what you visit. Do your research. Don't randomly use browsers. Okay, here's the kicker, though, is this guy right here. The GET request includes a range. So the GET request doesn't just say, hey, give me that file. It says, hey, give me the file, but it provides a byte range. So because it provides a byte range on this GET request, it gets a 206 partial content. Okay, and the partial content then begins. And this tells me it is a PDF file right there. So if you look up %PDF, well, I mean, first off, you know, it looks like a PDF. It looks like a PDF. You don't know if it's a PDF just because it has .pdf in the name. Don't forget, names are nothing, right? A suffix, I can change that all day. This, however, is a file signature for a PDF. So we've been talking about file signatures. I think I could just Google that. Oh, good. You guys are on that like that. You know what? Let's make it easier. PDF file signature. Hey, look at Scary's site. Boom. Sent PDF. So PDF files, there's an entire structure to PDF files, but I don't want to transition too much into computer forensics at this point. However, A PDF is going to contain the table, it's going to contain objects, it's going to, well, the header, the objects, and then what's called an X reference table. And in fact, the certification I just took, the malware reverse engineering, required me to go over a bunch of PDF analysis, which is making me right now want to go in depth into PDF analysis, but that's not what we're here to do. So moving on. We have a PDF file, whatever. We scroll down. Objects, PDF objects. We keep scrolling. We keep scrolling. More PDF objects. And then it just ends. Why does it just end? Because there's no, where's the XREF table? This isn't the end of a PDF file. What's going on? Well, don't forget, there was a range requested. So we have a 206 partial. Okay, let's do this. Let's take a look at both sides of the conversation. Here's the request in red, right? And here's the response. The top portion, then the actual data starts to come down, and then it just abruptly ends there. Let's save this. I'm going to save the response. Save as, and let's put it somewhere else. Session 5, and let's call this, let's just call it 206. All right, part 1.bin. Save. I'm going to close it. I just called it part 1.bin. Now we're in stream 0. If I change to stream 1, and then right click, follow stream, you see here, same GET request, right? But look at this. The range has increased. So beginning where we left off, and then going to that, which looks to me like, I mean, assumption, I would assume it's the end of the file. Do I know that? No. But at the same time, if I just scroll down, here's more PDF data, and then at the end, we have end of file, start XREF. I mentioned that the XREF is part of the PDF structure, and then end of file. So this is the end of the PDF. That's how you know it's the end, because you scroll down and you see that, pretty much. Okay, well that, and for that matter, when we originally, let's delete our filters, our request, oh no, our response code, remember we had two responses. So I simply just, when I did the first one, it gave me stream 0, so I just incremented that to stream 1 on the assumption that that would be the remainder of the data, and I was correct. However, assumptions, not so much, right? So let's do it the right way. Doing that response code. Come on. And you'll see the second one, right click, follow stream, and then you'll notice that, yeah, we're in stream 1 now. All right, so I kind of took a shortcut to find this, but this is the way you would normally do it. Okay, so the difference here is the range there, and then the rest of the remainder of the data. Let's look at both sides of the conversation. There's the request, and there's the response. I'm going to save the response. Save as. And where did I go? 206, and we'll call this guy part2.bin. Save. Close. Minimize. Back up a directory, 206. All right, I have part 1 and part 2, right? We're going to open, actually, where am I? Workshop, session 5, 206. All right, part 1 and part 2. I'm going to open Bless. Bless is a hex editor on Linux. You know what? I keep using, I recommended, what was it? HXD, but I don't think I've used it yet, so let's use it. Let me copy these out to my Windows machine. One moment. I'm going to go to my Windows machine. Desktop. Copy the data over here. Here, I'll walk through this process using a Windows hex editor this time. Last time I used Bless, which I was going to do again, but you might be more comfortable in Windows. Don't forget, there are numerous hex editors out there, and they're all great. I love them all. Well, not all of them. That's a lie. Most of them. All right, here you go. Okay, here are my 2 files. There we are. And oh, wait, what did I say I was going to use? I forget. HXD, right? What? Do I? Oh, I'm blind. It's right there. Okay. Okay. So I take part1.bin and I take a look at it in a hex editor. Now the first part I have in the hex editor is the HTTP response stuff. There. Well, where does the file start? Well, I know the file header is here, right? Remember this is part of the file header? Well, you need to be sure. So where does the file header really start? Well, if you look at Kessler's document, let's see, is this machine on the internet? I don't think it is. Oh, it's not. Oh, booger. Well, I don't want to switch screens again, so let me just do this. We have it as a resource. We saved the freaking thing, right? Copy it. Come on. There you go. Sure. I accept that. PDF. Hey, there we go. All right. Yeah, I save Gary's page. Whenever there's an update, I save it. Heck, I have a version of it printed out just in case I can't get to the internet. I don't know. I love his site, if you can't tell. So %PDF is the ASCII representation. What do you really need to be looking for, though? This. 25, 50, 44, 46. Let's go take a look. Oh, look, it's right there. 25, 50, 44, 46. And yes, it does begin at that part right there. And if you remember from last week, do you remember ODOA? ODOA? Do you remember what that is? Anyone? Raise your hand. It's line feed, carriage return, line feed, carriage return. So, in other words, we have this is the HTTP response stuff, and then we have two empty lines, and then we have the data starting for our PDF file. As such, I'm going to take all of this and delete it. You sure? Yup. And then I'm going to do a save as. I'm going to save it as a PDF. However, this is only the first portion of the PDF. So in a text, in fact, by the way, one of the cool things about PDF files is that it is literally just a bunch of strings of text. So I have, let me see, do I have bin text in here? I do. Okay, cool. All right, I take this PDF and I drop this sucker onto this tool called bin text, binary text, and I scroll through and I see all these strings and all these objects and all this fun stuff. And for that matter, you don't even need bin text. Just open the freaking thing in a notepad. Check it out. Wait, don't do that. Don't open it in notepad. Yeah, never mind. Bad idea. But you can run strings on this or just use a program like bin text or literally run the program strings, which I don't know if I have that. Oh, I do. Okay, cool. Oh, what the heck is it in Windows? No, Windows. Oh, I don't know. I'm blanking on Windows. More? More, right? Hey, it's more, okay. I'm just pressing space. There we go. We see our objects, some other silly stuff, and some objects. So just looking at strings. All right, I'm getting too much into computer forensics here. Backing off. Let's try this. We have a PDF file, right? Double click. Fail. There was an error opening this document. The file is damaged and could not be repaired. Oh. Well, don't forget, we only used the data that was in part1.bin. We didn't even touch part2.bin. Let's open part2.bin in a hex editor. Oh, whoops. I said we're going to use HXD, so let's stick with that. And hey, look what we get here. We have, again, we have our HTTP response up to here. And then we have these guys. You have to be familiar with those because if you leave those in, you're going to have a bad time. And then we start our data here. So let's take out the HTTP response along with the two empty lines. We delete that. And if you remember, this is the second portion to our PDF file. See, there's the PDF object stuff right there, readable. And then the last part should be the end of file and the xref. Yeah. So this is the end of our PDF. So what do we do with this? Well, we highlight it all. We copy it. And we open this file. And we simply go to the bottom, all the way to the right, and we paste it. Hit OK. Save it. And now we have our reconstructed PDF. You scroll up and down. But the real test, what do you want, part 2? No, don't say part 2. Just double click. Oh, hey, look, it's a PDF. So we reconstructed the PDF quite simply. Cool. All right, let me switch back over to Callie. Where'd he go? There you are. All right. Hey, come on. There we go. Cool. So we reconstructed it. Pretty easy. Let's try one more. This one looks big. Example B. I have not opened B and C yet, so let's just see what we get here. All right, this one's in 3 parts. How about this one? How about C? Hold on, let me open up C also. How many parts is this in? Oops. Ah. Oh, goodness gracious. This one is really chunked. Oh, wow. Yeah, look at that one. Oh, man. I'll leave that as homework or, like, busy work if you want to do that. I don't want to do that. Oh, they're individuals, that's why. They're little ones. All right, so forget example C. I'm not touching that thing. One thing I do want to show you is that in example A, we reconstructed it, but I mean, if you just go to File, Export Objects, HTTP, check it out. You get both pieces, but if you save these and you try to open them, good luck with that. But what you could do is you could hit Save All, and then save it somewhere to a directory, and then put them together yourself. Now, when you do it this way, in fact, take a look at this. Save all. Let's put it on the desktop. Create a folder. Testing. Save it. Some files could not be saved. Aww. Which ones? What do you mean couldn't be saved? Forget you. Go to desktop. Testing. Oh, it couldn't save anything. Why not? Well, I didn't want to save the partial file. Aww, man. That's why we went through manually and carved it out. In fact, now I'm just very, very curious. Let's see something here. We're going to try to use Network Miner. Oh, by the way, did I mention that you can use a program called Mono, which is a .NET framework so that you can run Network Miner in Linux? I don't know if I mentioned that yet. If I didn't mention, if I already did, well, whatever, deal with me doing it again. But if I didn't, you just do a Network Miner, what? Network Miner Mono. And it takes you to this article right here. I feel like I've already done this with you guys, but whatever. If I have not already done this with you guys, cool. Network Miner is a .NET program. Mono literally just is a .NET framework. And it even says here, Mono is a software platform designed to allow developers to easily create cross blah, 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 blah. Oh, here you go. That's why it's in bold. Mono is an open source implementation of Microsoft's .NET framework. Bam. So you're not emulating. You're literally just running the freaking thing. So how do you set up Mono and Kali? You do that. That's it. You just run this stuff. So you need to install this guy, and then you need to grab Network Miner, and then you change some permissions, and then you just freaking run Mono Network Miner. It's pretty simple. So install Mono, unzip Network Miner, set some permissions, and then run the damn thing. And here's an example, or even better, here's it live and in person right there. So what was it that I wanted to do? I'm here for a reason, right? What was that reason? I'm pretty sure I wanted to open up, yeah, this was the reason. I want to open up example A in Network Miner and go to Files and see what happens. Yeah, check it out. See, even Network Miner does this. I get from, in fact, this could really throw you off. Yeah, destination source, oh yeah. Yeah, this would really throw you off. Check it out. Oh, that's a good thing we're going over this. Check this thing out. Okay, so I open this file in Network Miner, and I'm looking now, and I see that the stream is probably difficult to see. Hopefully it's not blurry, and you're getting the HD version, because I can't zoom in on Network Miner. So we got to just deal with that. Yeah, okay. Well, anyways, I see protocol get normal. Get normal. And look at this. I have a file, and then it looks like I have the same file again. However, if I open the folder, if I oh, is that actually opening it? Wow, it is. I didn't think Mono would do that. Cool. Wow, that's a really good framework. All right, anyways, I have a PDF, right? And then I have another PDF, right? I double click. Document viewer is like, I don't have to do with that. And if I do this, CD, oh gosh, where are you? Come here. Oh, what? That should be enough. All right, there. So I try to do this. I just went to the reassembled directory is all I did, and then I'm going to I'm going to look at one of them. Oh man, they're named the same freaking thing. That sucks. I have to type things. Alright. I open up first one and bless the hex editor that I installed in Kali. Check it out. When you do it in Network Miner, it strips out the HTTP response stuff, which is nice, but we start off a PDF file here, and then it just abruptly ends. See? What? So, if we then take, just minimize you for now. No, I'm going to quit it. The one called like this, right? Yeah. And the second one starts off, look, there's the 8061 that started off our other file, and we go down to the end there, and there's the end of file, so you can reassemble these fairly easily. Let's see, does this give me what I want? It sure does. So I say, give me all this stuff, all of it. Copy. Control C. And go to the end here. Paste it. Save it. What? Oh, yeah. Just ignore that error. That doesn't make any sense. Fixed.pdf. Save it. It basically just takes all that, even to extract it using a tool like Network Miner. And there it is. Fix.pdf. Bam. So even tools like Network Miner and Wireshark with automatic extraction capabilities are not going to parse these files for you. I would have to assume that there's some option or preference in Wireshark that you can set so that Wireshark will manually reassemble it, or automatically reassemble those, because I would find it hard pressed that that doesn't exist in Wireshark. But I'll tell you the truth, I don't know what that option is, which is why I just manually do it. In fact, hold on here. Wireshark 206. Oh, that's a rabbit hole. Let's back up on that. Bugs. Oh. Manually carve, exporting data. There's no 206 there. Oh, hell, maybe it doesn't. Maybe it's not in there. I'll take a look at that a little bit later. But this can confuse the heck out of someone if you're using an automated tool like this, because you'll think there's two different PDFs. And people who don't know much about forensics or file structures or hex editors, for that matter, will be horribly confused why these two don't work when you try to double-click them. Huh, cool. I'm going to go back to our notes. All right, I want to mention just two more things, and then we'll wrap up here today. So one thing is I've mentioned promiscuous mode a couple times, I think. I'm not sure everyone's familiar with what promiscuous mode is, though. So we have an article on what it is, and then we have an article on how it's used in Wireshark. So let me just copy these suckers out. All right, and then change screens. A minute. All right. Okay, and then we do this. All right, promiscuous mode. In computer networking, promiscuous mode, or promisc mode, is a mode for a wired network interface controller, or blah, 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 that causes the controller to pass all traffic it receives to the central processing unit, rather than passing only the frames that the controller is intended to receive. What does that mean? Well, it means that if you're on a switched environment, if you're on a network where you have other people also connected to the same local area network, normally you're not supposed to be able to sniff their traffic. But if you put your network card into what's called promiscuous mode, you are then able to sniff all the traffic flowing through the network. Wireshark and other tools use this mode often. In fact, here's a link. Some applications that use promiscuous mode are listed here. And of course, you're going to have TCP dump and Wireshark because those are the big guys. And then other stuff that just happens to use it. So even Snort will do it. The intrusion detection system Snort, it will do that so that it can look at all traffic on the network. That's actually how it works. And if I remember correctly, yeah, I think this is it. There you go. All right, WSAIO control function is the C function. For, again, programming, you guys are programmers, right? Is a C++ function that's used to put a controller into promiscuous mode. And I believe, no, it's one of these. Where is it? It's not, no, it's return value. Hold on. Oh, this article's long. Receive all is what you pass to it. Oops. Oh, there's a lot of stuff in here. Jesus. Jesus. All right, isn't it receive all? Oh, yeah, there it is. All right, so this guy right here, SIO receive all, enables a socket to receive all IP. Oh, I'm sorry, I should zoom in. Here you go. To receive all IPv4 or IP6 packets passing through a network interface, the socket handle passed to the control function must be one of the following, and then the socket types are listed here. Anyways, to put your card into promiscuous mode, if you're writing your program in C or C++, you have to use this constant along with WSAIO control. So, just a little random programming thing I'll throw in there. Okay. So, and then there's an article for, what is this? No, this is the Wireshark article itself, and then in the functionality section, right up toward the top, why did I flag this? Oh, right here. Wireshark allows the user to put network interface controllers that support promiscuous mode into that mode. Why? In order to see all the visible traffic, not just the traffic that's been directed to that interface controller. Cool. So, let's get a visual. Okay, what am I doing? I want to show you a capture. Okay, look, down here. We have our interfaces on the left-hand side, right? And if I go to capture options, I think it's in here. There it is. We have, wait for it, right there. use promiscuous mode on all interfaces. By default, this is on. If it wasn't on, you would get some silly results, or I should say you would get a lack of most results when trying to sniff the network. So normally this is enabled, and you'll see this column right here, promiscuous mode, has its own column right there, right? If I have this selected, use promiscuous mode on all interfaces, these are all enabled, right? So you can set them individually, or you can set them like this. But yeah, when I double click, let's just say it's off, right? Like, see right now they're all enabled. I turn it off. Well, how do I enable it? It's because I can't right click here, so what do I do? Well, if you just double click, it's right here. Capture packets in promiscuous mode. Wireshark, there's so many freaking things in Wireshark that you can do. It's amazing. So this tool is extremely complicated. There's all kinds of fun stuff that you're going to find in here, but this is just one of the most basic things, is that it captures in promiscuous mode. And for that matter, hey, check it out. It even gives you a tooltip, a little pop-up that you're seeing there, that explains what this is doing. So cool. All right. And we'll just close that and close that. So I really just wanted to kind of briefly explain what that is. I'm going to delete this because I'm bothered by the fact that I just failed with this. You go away. You go away and you die. Alright, what else do we have? Oh, I also wanted to mention ARP poisoning. I brought this up last session. I think I mentioned it more than once. As such, I want to show you what ARP poisoning is, and I want to show you how you would detect it in a packet capture. You can't miss it in a packet capture. It's really easy to see it. So ARP poisoning is another term for ARP spoofing. ARP is the Address Resolution Protocol. It's what's used by machines to resolve the names, the MAC addresses, and the IPs and stuff. It's basically how devices join the network at the lower layer, at layer 2, so the data layer. So, ARP spoofing. What is this? What's this about? Well, it's a technique. You know what? Here's a visual. Routing under normal operation. LAN user. This is you. This is your switch. This is your gateway. That's the internet. ARP poisoning does the following. It bypasses the hub or the switch. This is you on a network at Starbucks, wireless network at Starbucks. This is me after I've ARP spoofed the network. And this is the gateway, and that's the internet. Everything you do now comes through me and then goes to the gateway. I mean, it still goes through the switch, which is why it's here, but you'll notice instead of going whoop like that, you're actually coming to me and then going out. So a malicious user will run an ARP spoof utility, and these are normally used for what's called a man-in-the-middle attack. A man-in-the-middle, if you're not familiar, is exactly what it sounds like. In fact, they're probably going to have a picture. Oh, this one's pretty simple. Here's an illustration of a man-in-the-middle attack. Alice is trying to communicate with Bob, but Mallory interjects herself in the middle. Yeah, and there's a whole thing about Alice and Bob. Yeah, you know what? I'll tell you what, the best picture for man in the middle is this. This is the epitome of man in the middle. This might be what ARP spoofing is, but it's also the epitome of man in the middle. So if I funnel all your traffic through me, then I can see what you're doing. And for that matter, I can modify the requests that you make that are going out if I want, and I can modify the responses you get in if I want. So ARP spoofing can be done with numerous tools. In fact, there are some that are included with Kali. Wait, how do you Control plus? That's what I'm doing. It just gives me this. What? Oh, we had this problem last time. I'll just do it normal. Just do it the manual way. There we go. All right, go away. So there's a program called ARP Spoof as one of them. So let me just do a man ARP Spoof. There you go. It even says intercept packets on a switched LAN. Check that out. What? What does it do? It redirects packets from a target host or all hosts. Forging ARP replies. This is an extremely effective way of sniffing traffic on a switch. Okay. Another tool is EtterCap, which can do a whole lot more than just ARP spoofing. But if I run the manual page for EtterCap, I see it's a multi-purpose sniffer and content filter for man-in-the-middle attacks. Ooh, what? Yeah, so this is where the real fun comes into place here. But EtterCap can be used for so much. If I scroll down, I'm just going to go to the last part here and scroll up a little bit to the examples. So here's the examples portion of the man page, and here are 2 examples using ARP. So when you run EtterCap, -T means text-only mode. It has an interface, by the way, a GUI, but I don't like that, so I do -T. -M is like modular method or whatever. It basically means, you know, what module you're going to use, and we're going to use ARP. And then this is dangerous. Oh man, you're going to ARP poison the entire freaking network. Just everything's going to be ARP poisoned to you. Now, let's say you're at the airport, and okay, let's just not say it's you, because we're going to talk about attacking, so let's pretend it's not you, okay? Let's pretend that some unscrupulous people or person is at an airport, because I've never done this ever, and this person wants to ARP spoof users in the terminal who are connected wirelessly. And they run something stupid like this, because they don't know what they're doing. If you run this, you're telling everyone who's connected to your airport wireless network, you know, if you're at the airport, right? You're all from Phoenix. If you're in the Sky Harbor Airport, right? You're telling everyone who's connected to that wireless network, hey, funnel your traffic through me. That's kind of dumb. All right, you don't want 100 people plus to all of a sudden come funneling through your network interface card. You're going to become a major bottleneck and probably bring that network to its knees. So what you would rather do is you would do something like this. So we're going to do text-only mode. We're going to use ARP. We're also going to do this guy. This is different. ARP and ARP remote are different. You want ARP remote. So, and it even says right here, the remote option is needed to be able to sniff the remote traffic the hosts make through the gateway. So you want to sniff all the traffic, not just it terminating at you. You want it to go through you and continually capture everything on both sides. And then you can specify, like, I want to ARP spoof between these guys. This is your man-in-the-middle configuration. This is the gateway, and these are the hosts that you want to attack. 2 to 10. Well, you're going to attack everyone. You're going to tell this guy, hey, these guys, they're me. And you want to tell these guys, hey, this guy, that's me. And they go, okay, and they start going through you. All right, so there's also I like the queue option to tack that onto EtterCap. It's quiet. Otherwise, if you don't do quiet, it freaking shows you sniffed packets as they arrive on the network, so your screen is constantly moving, and it's very annoying. So what I'm going to do is I'm going to just run this guy right here. We're going to copy that, quit that, clear that. We're going to open up Wireshark. And let's see, let me check my VM configuration here. Yeah, we're just using my Wi-Fi. We're good. Okay, what are we doing here? I'm going to capture. So we're going to capture on ETH0. Wait, hold on. We're going to capture on Ethernet 0. Start. And we've already got a bunch of traffic. Ooh, a whole bunch of traffic. Oh, that's Skype. I was going to say, wait, what the hell is UDP traffic? That's my Skype client and my streaming client, obviously. So 2 things going on. There's a stun protocol. Stun just popped up. That's for the Google Hangout stuff. So right now we're actually it's kind of funny. We're streaming the video and we're capturing the stream of the video and we're watching it on the video. That's just funny. So yeah, there's no way for me to quiet that if I want to capture what I want to capture. Could set up another interface, but that's boring. So you know what? I can't do this live. What am I doing? if I do this live, we're going to lose our video. That's dumb. Well, let's try this way. Let's just pick some IPs that are not technically active right now. What am I doing? All right, I want this guy. All right, I was gonna ARP spoof the entire network, but that's stupid because I'm on my wireless network, so I don't know why I was thinking of doing that. Let's do this. All right, our gateway. You know what? Where's the gateway on? Yeah, it's just my one. So we're at 118 here. Let me see what my Mac is on. One moment. My Mac is at 117. My network attached storage is on. Let me run ARP-A on my Mac. Hold on, I want to make sure I don't pop this offline because that'd be pretty stupid. All right, so there's my Mac and the VM interface there. All right, let's see if this even does anything then. Yeah, that should be fine. Okay, so here's what we're gonna do. We have our packet capture going crazy because we're streaming. I have Skype open. I saw that pop up for a moment, but most of this UDP is the Google Hangout YouTube stuff. So I have nothing running on .200 or .210. I'm gonna ARP spoof to them, and if it drops the video, well, then I'll just see you guys next week. Right? We're basically done anyway, so I'm just gonna do it. Let's see what happens. Ready? Here we go. You're being too noisy. Go away. So unless those devices are connected, it's not actually going to do it. Phooey. Yeah, guess I can't do a super live thing with you. Let me quit. Hit Q to quit. ARP Poisoner deactivated. Ignore the IP tables thing. Just close that. All right, let me stop this and let me just check this. Oh, no, we're good. All right, check it out. So how do you see something like an ARP spoof attack? Well, we picked it up. Cool. If we filter on ARP, can you guys see that? Yeah. We filter on the ARP protocol. Up at the top here, we see ARP protocol, and then we have, this is my Macintosh, the 117. And then who has 118, which was the Kali Linux VM that we're in now. And then we have, I'm running a Netgear router, by the way. And then we got, whatever. And then all of a sudden, well, no, this is also normal. These are normal, normal. And what time frame does it happen here? There we go. What time is it now? What time's off? Oh, were we at UTC? Is this UTC? What time is it? Wait, I'm looking at like 5 clocks right now. All right, it is 9:50 plus 7, 16:50. Yeah, it's just in UTC format. Okay, whatever. So, yeah, this is my actual, this is my Windows computer, and this is the router, and then it's like this is where it starts here. So check it out. All of a sudden, notice that most of this is who has a certain IP tell the gateway. Because the gateway is the one that says, hey, who's this IP? Give me your MAC address. And the machine goes, okay. Right? But then all of a sudden we have 118. Tell 118. Who's 118? Well, that's my Linux VM. So when we were just running Ettercap, oh, I closed the window already. Whatever. When we were running Ettercap and we were doing the man-in-the-middle spoofing, all of a sudden the gateway is now purported to be this 118. So router, it's like, hey, you're going to do some stuff through me. And then who has 205? Who has 209? How about 7 and 2 and 8 and, excuse me, 1 and 10 and 6 and 3 and 204 and blah, blah, blah. Now, why was it doing all that? Well, that's because we ARP spoofed 200.200 to .210. So if one of these devices was actually online, you would then see the response go back to the gateway, at which point now that sucker is going to use that as its gateway. So essentially, when all of a sudden you start seeing stuff like this, an ARP request broadcast, it's called a gratuitous ARP, by the way. I wonder if it'll say gratuitous. No, it just says request. All right, it's a gratuitous ARP, which is used. Oh, I don't even want to get into that. You can look at this stuff here. Gratuitous ARP replies to which no request has been made. Actually, these are not gratuitous, but they can be used in EtherCap with this switch. More on that never. All right. Once you start seeing telling the request to tell another device that's not the gateway, there's usually an ARP request or an ARP spoofing going on. So that's how you can kind of identify what's going on. And there are scripts out there. You know, I just made that up. I would assume there's scripts out there, otherwise we could make one, that basically looks for the initial gateway in the packet and looks to see if that changes in the ARP requests. And there are some tools out there that I'm not 100% familiar with that will look for ARP. In fact, I think ARP Watch is, oh look, yeah. ARP Watch, keep track of Ethernet IP address pairings. There you go. So ARP Watch is one of the tools that will look to see if ARP is being spoofed on a network. So, all right, cool. In fact, so ARP Watch would have to use promiscuous mode then. Yeah, I wonder if it says anything about that. Nope. Okay. And that is all I had for today. So I do want to show you one little quick tip here. I'm not sure if everyone's aware of this, but it's fairly handy. If you have a switch on a program and you're not familiar with what it does, for example, I see an example on the internet. It says EtherCat TQ, right? And I want to know what that means. Well, how do you find that out? Well, obviously, you do it by doing man EtherCat and then scrolling down and scrolling down, waiting until you find the switches. All right, here's switches. Here's T, text-only mode, and then Q is quiet mode. Okay. So instead of doing all that, you can just pipe it to grep, and literally search like that. Oh, hold on. Search like that. And you can also do like that. See? If you just grep, by the way, you're escaping. This means escape, otherwise it breaks. It doesn't know it thinks it's a literal. So you have to make it a literal dash, not used specially in your grep statement. So there it is, it's quiet. Now you can also get a little more information in grep by using A, B, or C. A means after, so after my match, I want to show a certain number of lines. I want to show 2 lines after and 2 lines before. C is basically setting A and B at the same time. So this is functionally equivalent to this. So A2, B2 is after 2 lines, before 2 lines, and C, any value means before and after that many lines. So it's very handy to do C1 when you're going through man pages, but I typically run C2 or C3. So the other one is we're looking at M. Remember M? Whoops, I did not. What did I just do? Hold on. C. I meant to do it here. There we go. Too many lines. Back. Let's just grab it. It's not technically method or module. It's the man in the middle. So you're going to use a man in the middle module. I just made the term module up. So there you go. That's what that is. Cool. All right, I just want to mention that in case you see some switches and you're wondering what's a quick way to identify what they do. You can just use the man page, pipe it into grep, and then just do a search. The trick is you have to escape the dash. So, in fact, I wonder if it has some of the examples. And let's see what the example is. Oops. That. As an example. All right. Huh? Huh? No, it literally just an empty example. All right. That was boring. Okay, so that's pretty much what I had for you guys today. So let me undo that. Okay, cool. That's the end of session 5. So we have 6 sessions. I'm not going to have any assignment or homework per se for this round. What I would like you guys to do is if you have a chance, if you've been catching up on the videos, if you haven't had a chance to catch up, by the time you got to this one, you've probably seen how to do the challenges already. But just because you've seen how to do it doesn't mean that you won't benefit from going through it. So what I'm getting at is go through the freaking challenges. They're fun. It's a good way to learn. You're going to always make mistakes. Speaking of making mistakes, I showed you an article that explained overlapping streams and partial 206 HTTP responses, and then I proceeded to ignore that and piece together a file without paying attention to stream overlap. We all make mistakes. I just made one on a stream, right? Whatever. It happens, man. So when you're going through them, if you're having trouble with following the video, or you're having trouble reading what I put in one of the notes, the official class notes, whatever, just send me an email. I'll respond. We'll get through it. All right? The last and final session, 6 next Friday, the 19th, looks like. When we do that, what I'm going to do is a lot of hands-on going through different puzzles and challenges. Some of them, in fact, I think the first one I'll research to make sure I don't screw the pooch on it, so to say. And then from there, I'm going to go in blind, and I'm just going to see what the heck happens. You're going to see me fail, most likely. You're going to see me try a couple different things. I might spend the entire thing stuck on a challenge and then end the stream after 2 hours pissed off. I don't know. We're going to find out, though, right? So we're going to have fun in stream 6, or in session 6, stream 6. It's like life's a packet capture. We're going to be in stream 6 now. All right. So that's all I have for you guys. I will see you guys next week. Peace out.